All right, it's Friday. Let's get on with the test review. So it's going to be simplifying radicals and finding all 6 trig ratios for a given angle theta. So let's get the simplifying radicals part out of the way, since that's going to be important for the next test. Anyway, so let's start off. See if you guys can do, sorry, I have all the scribbles right there. See if you can do these 5 problems independently. The square root of 75, square root of 20, square root of 96, square root of 900, and square root of 512. See if you can do those problems independently. You can use the pause button right now. Okay, so let's start off with the square root of 75. Well, in other words, we're trying to simplify the radical by factoring, by breaking down 75 into its factors and pulling out the perfect squares. So let's make a multiplication problem that makes 75. Well, when I think of 75, I think of quarters. So I know that I can factor out 25 and 3. And again, you could have done 5 and 15. I think those are the only choices that you really have other than 1 and 75, which doesn't really help you. That being said, you've got options from here. I could break this down into radical 5, radical 5, radical 3, and circle the twins. But you know what I like better? I like knowing that there's a perfect square right here and just pulling it out, and that becomes a 5. So this whole thing can become 5 radical 3, because the biggest, sorry, I can't break down radical 3 because it's prime, and that seems to be the only way I can fully simplify this. Okay. Number 2, the square root of 20. Well, I have 2 options. I can do radical 2, radical 10, or radical 4, radical 5. So I showed you the method with the perfect square. I'm going to show you the method where, what if we chose radical 2, radical 10? Can I break down 2? Nah. But can I break down radical 10? Yeah. Specifically, I leave this radical 2 alone, but this radical 10 can be broken up into radical 5 times radical 2. But you know what? I'm going to write it like this. Radical 2, radical 5. I can't break down radical 2 any further. I can't break down radical 5 any further. These are its prime factors. So in this method, radical 2 times radical 2 can factor out a 2. And that leaves me with 2 radical 5. The other way I could have done it was radical 4, radical 5, and that radical 4 can turn into a 2. All right. Number 3, radical 96. So the square root of 96. Let's see. What can I do here? Well, I know I can divide by 2, and then I divide by 2 again, and I still get a whole number. But I'm just really, years of experience with this. I'm going to pull out a 4 because I can. Well, if 4 can go to 100 with quarters, 4 times 25 is 100. So then 4 times 24 can be 96. Well, actually, you know what I can do? I pull out that radical 4. That becomes a 2. But then this radical 24 can be broken up into, well, you've got options. I can go 2 times 12, I can go 3 times 8, I can go 4 times 6. So I'm going to break this down into radical 4, radical 6. Well, now I've got this, sorry about that, let me pull out a red this time. So this radical 4, yet again, is another perfect square. I can pull that out and make that 2. And I don't really have much I can work with radical 6. I mean, I suppose I could break this down into radical 3, radical 2, but I can't break those down any further. So fully this becomes 2 times 2 times radical 3 times radical 2. Since I can't pull out another square out of this, this whole thing becomes 4 radical 6. Okay? So that's the best way to simplify the square root of 96, and I know I was using a calculator, but That's how they used to simplify a radical before a calculator. Okay. Number 4, the square root of 900. Well, I suppose I could do the square root of 9. Oh, wow. I just did the square root of 9 times 100, and I was like, oh my god, wow, that's amazing. So that's going to be 2 perfect squares together. Square root of 9 is 3. Square root of 100 is 10. So this whole thing is literally 3 times 10, or 30. And it makes sense because 30 times 30 is 900. I'm surprised I didn't see that immediately. I just got these from the book. Anyway, so back to radical 512. I was going to write 152, and I was like, no, 512. 512 is what I want. Anyway, so I try to pull out a big number if I can. So I'm going to get the calculator. 512 divided by 2. Of course, it works. Can I divide that by 2? Yeah. Let's just say I do. Let's just say I shoot for the home run. 512, does it divide by 8? Oh, wow. Let's see if I can do 512 divided by 16, because 16 is a perfect square. I think that meets in the middle. So let's say I do radical 16 times radical 32. That's a huge help. So there's a lot of ways I can go about this. And again, I'm doing this on the spot because I want to struggle with you guys. And I don't mean struggle as in like I want you guys to do horribly in math. I genuinely believe that the process of this is more important than just here's the answer. So there's a variety of ways I could go about this. I could break this. Actually, you know what? I'll show you the straightforward way. I would bring this as a 4. And now there's a variety of ways I can manipulate radical 32. You see, I like radical 16 times radical 2 because the square root of 16 is 4 as well. So in the end, I've got 4 times 4 times the square root of 2, or 16 square root of 2 is how you simplify that radical. Okay? Alright, so now I'm going to move on and do find all 6 trig ratios for angle theta. So you've got a right triangle. I've got a length of 7 and a length of 24. Well, the side length that I don't know, and again, the test will have a diagram like this. It'll have 2 sides that you know, and it'll ask you to find all 6 trig ratios, but you don't know the third side. So I got leg, I don't have the hypotenuse. So I'm going to do leg squared plus leg squared equals hypotenuse squared. Remember that we really care about leg squared plus leg squared equals hypotenuse squared. So I've got 7 squared plus 24 squared is equal to, I'm going to call this x. So now I've got x squared as the hypotenuse. Thank goodness I don't have to do a lot of algebra. I've got 49, but now I'm going to get my calculator out here. 24 squared, 576. So 49 plus 576 is equal to x squared. I'm just going to round up to 50. Okay, 50 plus 576 is 626. I'm going to subtract 1, that's 625. So 625 is equal to x squared. And now I'm going to square root both sides. And the square root of 625, I believe is 25, but I'm just going to make sure. First off, 625, and then I'm going to square root. Oh, and and that's going to get me 25. So 25 is equal to x. Phew, it's a whole number. So that's my unknown side length. I'm just gonna, this is just the way that I do it because I like it when all the information is in front of me. So now I'm just gonna redraw the triangle. I've got 24, I've got 7, and now I've got 25. And my angle that I'm focusing on, my angle theta, is right here in the corner. And now I'm gonna do sine, cosine, tangent, and the reciprocals. Okay, the sine ratio is the opposite side to its hypotenuse. So the opposite side of angle theta is 24, and the hypotenuse of the triangle is 25. So that's my sine ratio. And then I'm going to do my cosine ratio, which is adjacent to its hypotenuse. So that's 7 over 25. And then my tangent ratio is the opposite over the adjacent side, so that's 24 over 7. And now, can't reduce any of them, so I'm going to move on to cosecant, secant, and cotangent. So my cosecant ratio is the reciprocal, 25 24ths. My cosecant is my reciprocal of sine. My secant is my reciprocal of cosine, so that'd be 25 sevenths. And then my cotangent is the reciprocal of tangent, so that'd be 7 24ths. So there you go. I would box them, but I'm holding it with my left hand. I don't want to go through. I don't want to accidentally draw a box that goes right through my 6 trig ratios. But yeah, that's basically all that's expected of you for the second part of the test. So let's do some more examples. Okay, number 2. Let's say I've got 18, 30, and theta. What side lengths do I know? Well, roller coaster. I've got a leg, I've got a hypotenuse, and I don't know the other leg, so I'm going to just call it x. So I'm going to use the Pythagorean theorem. Leg squared plus leg squared is equal to hypotenuse squared. So let's say I've got x squared plus 18 squared is equal to 30 squared. And that's, I know that 30 squared is 900, but I don't know 18 squared, 324. So 18 squared is 324. Now, what do I do to isolate the variable? All right, I'm going to subtract 324 from both sides. So if I subtract 324 from both sides, well, so that'd be 900 minus 324, 576. So x squared is equal to 576. And because last time the square root of 900 snuck up on me, I'm going to see, can I do the square root of 576? 24. Love it. So x is equal to, sorry, if I square root both sides, I love it when it's a whole number. X equals 24. So I'm just going to redraw a triangle because that's the way my brain works. So I've got a 90-degree angle right there. So 24 is right there. 18, still where it was. 30, and my angle theta is right here. Now I want to do sine, cosine, and tangent. So my sine of theta, my cosine of theta, my tangent of theta. So I look at angle theta. What are going to be my sine, cosine, and tangent for this diagram? Once again, Another helpful hint, you can always put that somewhere. I'm just going to put right there. Just put it somewhere in your work. Helps me remember. So anyway, let's find the So the sine ratio is going to be opposite over hypotenuse, or 18 over 30. You don't have to simplify the fraction. The cosine of this angle is going to be adjacent over hypotenuse. So that's 24 over 30. And the tangent of this triangle, the tangent of this angle is going to be opposite over adjacent, or 18 over 24. And again, you can simplify it. It's your choice. 18 over 30 could be, divided by 6 on the top and bottom? You would get 3 over 5. You would get 4 over 5 here. Divided by 6 over here, you would get 3 over 4. But you don't have to. So therefore, the cosecant, the secant, and the cotangent are just the reciprocals of their respective functions. So the reciprocal of cosecant is 30 over 18. The reciprocal of cosine would be 30 over 24. So the secant of angle theta would be 30 over 24. And the cotangent of angle theta would be the reciprocal of tangent. So if the tangent is 18 over 24, then that means that the cotangent needs to be 24 over 18. And that's how you do it. Remember, toa. And then cosecant, secant, and cotangent are their respective reciprocal trig functions. All right, let's do number 3. So let's say I give you 14 and 10. Once again, I know one leg, I don't know the other leg, but I do know the hypotenuse, so that helps me out a lot. X squared plus 10 squared is equal to 14 squared. That's x squared plus 100 is equal to, I don't know my 14 times tables, 196. This just snuck up on me because we just did simplify the square root of 96, but I'm going to approach it with the same level of respect that I would treat any number. Except for 13, that's unlucky. X squared is equal to 96. So now I need to square root both sides, leaving me with x is equal to the square root of 96. And again, we just did this, so I'm just going to do a different pair of factors. Let's say I break it down, 96 divided by 8. Yeah, 8 and 12. So this breaks down into radical 8, radical 12. I can break this up into radical 4, radical 2, radical 4, radical 3, and let's just say I break it up all the way into primes. Radical 2, radical 2, radical 2, because this is radical 4, and then radical 2, radical 2, radical 3. I'm just going to circle the twins out. So I've got a 2 factored out, a 2 factored out, a radical 2, radical 3. So that becomes 2 times 2 times radical 2 times radical 3, or what we got earlier in the practice problems, 4 radical 6. So that was fun. But now I'm just going to redraw the triangle with the information that I'm given. So 4 radical 6 is the new leg. And we've got 14 here. And where's my angle theta? It's in the top right. So I'm just going to recopy it, and I'm just going to put all the information that I'm given. Now, again, I'm not going to simplify the fraction. You can if you so choose to, but I'm just not going to because it's Friday, got to get down on Friday. So let's do sine of theta, cosine of theta, tangent of theta. Cosecant of theta, secant of theta, cotangent of theta. So let's look at this theta. What is my opposite over hypotenuse ratio? My hand got a little bit of a cramp. Let me just shake that off really quick. Okay. So I've got opposite over hypotenuse, so that's 10 over 14. My cosine ratio is going to be 4 radical 6 over 14. And my tangent is going to be opposite over adjacent, TOA. So it's going to be 10 over 4 radical 6. And for the cosecant, secant, and cotangent, I'm just going to write the reciprocal trig functions. The reciprocal of 10/14 becomes 14 over 10. The secant is the reciprocal of cosine, so that'd be 14 over 4 radical 6. And the cotangent is going to be the reciprocal of 10 over 4 radical 6, or 4 radical 6 over 10. Okay? I would box them, but I don't want to be sloppy. But that's what's expected of you. We have time for one more. Oops. There it is. All right. So I wanted to end it where you simplify the hypotenuse. So once again, see if you can do this problem independently, and you're going to have to simplify the radical for the hypotenuse. So you've got 36 squared plus 78 squared, and I don't know the opposite side. I don't know the hypotenuse. I'm going to call it x. Well, I don't know my 36 or my 78 times tables. 36 squared, 78 squared. So 1296. Okay, so 1296. I don't think I was born that year. And 6084, I don't think I'm going to live to that year. But if I add these together, I'm going to get 7380. Well, at least I know it ends in a 0, so I can divide it 10. 7380 equals x squared. So now I'm going to square root both sides of the equation. So that means that x is equal to the square root of 7. So that means that x is equal to the square root of 7,380. But the directions are going to say simplify the radical. So therefore, why don't I break this down into, you know what, it ends in an 80. I'm going to shoot for 20 because I know that if you're what was it? I can't think right now. Right now it's literally 11:30 p.m. at night on Thursday. So basically, if the last two digits end in a number that's divisible by 4, it's divisible by 4. So 20 is divisible by 4. The point is I've had a lot of practice. 7,380. Let's say divided by 20. 369. Equal to x. Well, I know that I can break up radical 20 into radical 5, radical 4. Let's see. Can I break up 369 divided by 3? And can I break that up even more? So 369, I'm just going to divide by 9 and get 41. Well, in this case, I've got a perfect square here. That's going to be fun. So I've got a 2 I could break up there. And I've got a 3 I can break up here. And I'm just going to spoil it for you. 5 is prime. 41 is also prime. So, so this becomes 2 times 3 times radical 5 times radical 41. No, I'm not going to be this ridiculous on a test. Well, 41 times 5, I'm just going to take a shot in the dark that it's 205. Yeah, 205. So, believe it or not, the simplified version of this fraction, thank goodness we invented calculators. And you guys know that I'm only teaching this because California is making me. But, you know, if I had it my way, I would say round to the nearest 3 decimal places. Get the whole number and round to the nearest 3 decimal places. But you know what? California pays me, so no, I'm just kidding. But the idea is this would be the simplified way to this would be the most simplified way to write the square root of 7,380 without a calculator. So now I'm just going to rewrite the triangle. Six radical 205. 78 and 36. So, ka, toa. And where's that theta? Oh, it's in the top right. Okay, so I've got 90-degree angle there and theta. All right. So that's going to be 78 over 6 radical 205. The cosine of theta, 36 over 6 radical 205. Hey, if I simplify that fraction, that's going to be 6 over the square root of 205. The tangent is going to be the opposite over the adjacent, so that's going to be 78 over 36. And again, you can simplify these fractions if you want. I'm not going to make you. I'd rather you understand the big picture. Cosecant, secant, cotangent. Just take the reciprocal. 6 radical 205 over 78. 6 radical 205 over 36. And finally, 36 over 78 is your cotangent ratio. If there's any questions, please email me. Other than that, that's all that's going to be on the test. Wish you guys good luck. It is due Monday night. You'll be doing the test on Monday. So if you want to get a head start, I will email you by Friday, by the end of the night tonight. Have a great weekend.